Hello everyone, this is Cody Jackson with Cody, and we are continuing the Python course, and today we're going to be talking about loops. If you want to follow along at home, here's a couple of books that I've written. We are currently going through the Learn Programming in Python with Cody Jackson book. The Secret Recipes of the Python Ninja is for more advanced Python information if that is what you're interested in. So we're going to talk about while loops first. And basically what while loops do is nearly infinite looping, or if you mess up your coding, true infinite looping, as in it will go on forever until you kill the process. So while loops will continue the loop cycle as long as the condition that causes it to loop exists. If that condition turns false or does not exist anymore, then the loop stops. So to manage how the while loop works, not only are you going to have some sort of a condition that is checked every time the loop cycles, but you can force certain actions depending on what you as the programmer want to do. The break statement forces the loop to quit early. So basically it short circuits how the loop works. If it reaches the break statement, then it breaks out of the loop and goes back to regular processing. If you're in a nested loop, then it breaks out of the current loop and goes to the outermost loop. If you're not in nested loops, then it breaks out of the current loop and goes back to the normal linear logic flow. The continue statement forces the loop to restart early. So regardless of what's below the continue statement, it short circuits that process and jumps back to the beginning and starts the next loop. An else statement is somewhat unique to Python in that it gives you a on the way out of the loop set of actions to perform, and that's frequently used for cleanup of data variables, databases, tables, things like that. So if you use a break, you do not get the else actions. The break is literally just breaks right out of the loop and jumps right back into regular logic flow. So because the loop did not continue normally, you do not get access to the else. So jumping over to our IPython interactive interface, we are creating a loop. So our first action is to create a variable and assign it a number, and then we set the while loop. So while our variable is less than the value of 15, we are going to print out a string saying the variable I is less than 15, and then we're going to increment that variable by 1. So we have our operator here, which is a plus equal. So basically this is a combined operator that says I am going to add 1 to I, and then that value is going to equal the new value of I. You could do this in 2 steps and say I plus 1 equals I. You could do this in 2 steps saying I equals I plus 1, but there's no reason to because it's kind of redundant, so that's why they have the shortcut operator. So if I is not less than 15, then we have this else statement which basically says print when I is equal to 15. We run this and we start from 0 and go all the way up to 15, and once we say 15 is equal to 15, then the loop automatically stops. That's the condition. So we don't have to have a break in there because we're letting the loop do its normal process. If we set I equal to 1000, it would continue for 1000 steps. So break is only used if you want to break out of it due to a secondary condition. So here's an example. It's a little bit more complex in that it has a continue and a break in it. So we set a variable to 50, and we're saying while x, so while x is present or while x exists, decrement x by 1. If x modulus 2 is not equal to 0, so if x divided by 2, the remainder of that is not equal to 0, then continue or start the next loop. If x modulus 2, if the remainder is equal to 2, then print x. If x, our value up here, that's been decremented, is exactly equal to 10, then stop looping. Break out of that loop and continue normal operations. In this case, there's nothing further to do, so it just stops. So we start at 50, divide by 2, check the remainder. If it's not equal to 0, then we print it. And so we continue on down until we reach 10. Once we reach 10, we break out of the loop and we stop printing. So as you can see, what this loop does is it identifies all of the even numbers that are in the sequence 50 down to 10 and prints those values. So while loops are pretty simple. Once you get the hang of them, as long as your sentinel value, the condition that you want to continue checking, as long as that does not turn into an infinite value, it will exit. What you need to be concerned about is, do you want it to exit prematurely by using a break, or do you want to break out of the loop cycle and start another loop by using continue? And do you want to have some sort of an else statement in there that does some sort of processing when the looping is completely finished? So that's about it for while loops. We're going to jump into for loops right now, which are probably more common to see than a while loop because they handle sequence iteration. We've seen iteration before, so we've seen some for loops. We're just going to talk about them a little bit more in depth right now. So if you have a sequence, a for loop is basically what you're going to go work with. They have the same control statements as while loops, so you have your breaks, continues, and else. You don't need to worry about having a infinite loop, because a for loop only works as long as that condition exists. Unless you explicitly use a infinite value, you're eventually going to reach the end of your sequence. Because for loops are simpler and run quicker than while loops, they are the preferred loop for sequence manipulation. Yes, you could use a while loop, but a for loop just works a little bit better, and so that's why these are more common to work with. So what we're doing here is we start with our first loop, where we go 2 to 20, which is actually 2 to 19 because our indexes start at 0. Have a nested inner loop, which goes from 2 to whatever the current value of I is in that outer loop. And then we do a comparison. Well, not really comparison. We actually divide and say if the I value divided by X value, if the remainder of that is 0, then we print I equals X plus that remainder. And then we break out of the inner loop and start on the next I value. If I divided by X is not equal to 0, then we say that I is a prime number. It's a little bit complicated, but you should be able to go through this and confirm 2 is a prime number, 3 is a prime number, so on and so forth. You may not be used to seeing floats in your math, and that's just because when we use the single divisor sign, a slash, it automatically changes to float values. If we want, we can do an up arrow, bring back our statements, put another divisor sign in there, and that's going to truncate the output so that instead of getting float values, we get regular integers. So this is just something that you need to be aware of. If you don't want floating point values, if you don't want that precision, then you need to have a double division sign, and then that will eliminate any floating point values. So here's a common use of for loops. We set a string of just some words and a tuple of just a sequence of numbers for character in string. This could be for X in string, for underscore in string. This variable name here can be anything. It's just a placeholder. So don't think that you always have to use char when you are using strings. So for each variable or each value in the string, print it, and then just do not have a separator in between them. So basically it's just going to repeat everything that's in here: spam, bacon, and eggs, and it's going to include whatever is part of it. So that's what the end equals nothing implies. For our tuple, we have our sequence here, and you see that there is a comma in between them to separate each of the values. Now we do the same thing in our end parameter, and we say we don't want anything as an ending separator between them, and so it prints them all together. If we go ahead and we say end comma space, then it will automatically insert a comma and a space in between each of the values that's in the tuple. Beyond that, this is very common for working with for loops, where you are iterating through a sequence, strings, tuples, lists, whatever, doing some sort of a processing. In this case, all we're doing is just printing it, but it automatically stops once you reach the end of that sequence. And so this is very common for dealing with files, dealing with the text, especially if you're doing any sort of word processing, web applications, if you're catching a data stream of input or output and doing some sort of processing with it before relaying it on. You'll probably have some sort of a set delimiter in there that will say, for this number of bytes, do this process, then catch the next number of bytes, do the next process, so on and so forth. So that's it for loops. I want to talk about the zip function before we end this video. So what the zip allows you to do is to process multiple sequences and kind of combine them together. So you can have two or more sequences, and it joins the individual values into parallel tuples. So if you stacked your sequences one on top of the other, then it would go for everything in index position 0, so all of the first values, then all of the second values, all of the third values, and so on. Any iterable sequence can be zipped together, including files, because they're just considered streams of characters. One caveat is it only goes for the shortest sequence, basically. So if you have a list of 3 items and a list of 5 items, it's going to stop after that third item is processed. Why this is convenient is we had talked previously about using dictionaries or lists programmatically, wherein you don't pre-populate it as the programmer. You catch user input, or you catch some sort of dynamic data that's going to be coming into your program, and you capture it into a list or a dictionary. And so then what you can do is you can make a empty list and then fill it using zip. So we create 3 tuples of just integers. One thing to note is you have to take the object that is created by zip and expressly state that you want it to create a list or whatever it is that you want to do. So in this case, if you just run zip, all it's going to do is tell you the zip object was created at this memory location, but it doesn't actually output it. You have to expressly state, I want a list to be created from this object. And that's basically what we're doing here, is we're just saying, here's a list constructor, and populate it with the values from our zip. And so we have the square brackets, so you can see that this is a list of tuples. And so you can see the first value is 1, 4, 7, so it went vertically 1, 4, and 7. The next tuple is 2, 5, and 8, and the final one is 3, 6, and 9. So it went vertically through all of our sequences and merged those all together. And so that's how it works. So it's not joining those two together end to end, but vertically. Here is how we use a zip to create a programmatic dictionary. So we have some keys and we have a set of values. The keys are set as a tuple, the values are set as a list of strings. We set a dictionary constructor to take the output of zip, keys and values, and combine them into a complete dictionary. So index 0 is a 1 and Sir Gawain. Those are populated as the first key value pair in the dictionary. The second is 2 and Sir Robin, and the final one is 3 and Tim the Enchanter. So again, it has gone vertically and combined the first sequence with the second sequence, in this case creating a dictionary. So the number 1 is associated with the value Sir Gawain. So again, you can see how if you did not have values but you knew what your keys were, you could take a zip, fill it with the keys that you already know, and then the user input that comes in, and populate a dictionary that way. So that's it for this video. Pretty simple, pretty short. We looked at while loops, we looked at for loops, and then we talked about using the zip function to combine sequences together. Next time, we're going to look at exceptions, how to deal with errors, how to create your own errors and work with them, and in short, how to do more functional testing and work within your program to make the user experience a little bit better. Until that time, I hope you enjoyed this video. Please let me know your thoughts in the comments. Until then, have fun and continue learning. Bye.